Hello there. In this part of the course, we're going to explore the NumPy package on a deeper level. In this section, we'll talk about some of the fundamentals of the library, starting with indexing. Let's begin. At the start of every new notebook, we should first import the NumPy package as NP. Going forward, we'll assume you've already done this bit on your own, to avoid running the same line of code every time. Next up, with the help of the NP function, we'll define a simple two-dimensional array containing the numbers from 1 through 6 equally split into two rows. To make sure we've defined it properly, we can call array A on the next line. Perfect. Now that our array is defined, we can focus on indexing. So, we use indices to refer to the individual elements within an array. You can think about indices as coordinates that help us navigate throughout the array, since none of the rows or columns have names. These indices are integers, and by placing them in square brackets after the array variable, we indicate which values we're interested in. Note that Python, like many other programming languages, uses zero indexing. This means the value of the first position corresponds to index 0. The value in the second position has an index of 1, and so on. To grasp this better, let's call the first element of the array we just created. As we explained, we simply need to add bracket 0 bracket after the name of the variable and execute the cell. The output is the first row of array A. The reason we obtain an entire row as opposed to a single integer is that the array A variable is two-dimensional, which means that its first element is the first row. To avoid confusion later, whenever we're working with arrays of two dimensions, we'll call rows elements, while referring to the separate numeric values as individual elements. Having made this distinction, we change the 0 to a 1 and rerun the cell. We'll get the second row since it's the second element of the 2D array. However, if we change it to 2, we get an error message. That's because we're looking for the third row while our array only has 2. So let's change it back to 1 and continue. Okay, if we want to get an individual value from the array as opposed to a row, we need to provide an index for each dimension of the variable. In this case, since array A is a two-dimensional array, we require two indices. We write them one after the other, each within a pair of square brackets. For example, let's get the second value of the first row. To reference that first row, the first index must be 0. Then to reference the second element from this row, the second index must be 1. After running the cell, we see an output of 2, which is exactly what we expected. Great! If we wanted to get the first individual element of the second row, then we simply need to switch the indices around. We get an output of 4, so this works as desired. Before we move on, you should know there is an equivalent way to express these indices. We can have both values within the same set of square brackets, but separated by a comma. To try this out, just copy the code into a new cell and replace the inner pair of brackets with a comma. We see the same output as the cell above, so the two notations are equivalent. In this course, we'll rely on the second approach. However, both are widely used, so it's only a matter of personal preference to choose one over the other. The only thing we suggest is to be consistent throughout your code, which means try to either use two pairs of brackets or one. Next, if we wish to get an entire column of the dataset, we need to simply substitute the row index with a colon. This tells Python to go through all the rows from this column. The technique is called slicing, and we'll discuss it further in the beginning of the next section. Once again, the output is just what we wanted, a 1D array containing the first column of the initial 2D array. For now, think about it as an interval index, while the ones we've used so far will be specific indices. All right. Earlier, we mentioned how indices were integers, but integers can also be negative. So, a negative index value expresses traversing the array backwards. To showcase what we mean, let's define a new variable, array B, which contains the values 1, 2, and 3. Now, let's call the variable with index -1. The output shows the last individual element of the array, the number 3. But wait, if index 1 relates to the second element, why doesn't -1 relate to the second last element? Well, that would mean we use -0 to express the last element, but -0 is 0, so no such thing exists. Hence, Not surprisingly, negative indices start from -1. Of course, this works on 2D arrays as well. We already defined such a variable earlier, array A, so we can display it on the screen right now. In the next cell, we can call it with index -1. As expected, the output is just the last row. Just like with positive indices, we can also refer to a column, a specific element, or go out of bounds and get an error message. Hence, negative indices are just as viable as their positive counterparts, so you can use either if you are consistent in your code. Fantastic! Now that we know what indexing in NumPy is, we're ready to learn how to assign values to an array after defining it. Thanks for watching!